So this is called minimal operational intervention and other resilience principles. And the reason that I titled it this is based on a LinkedIn post that I did, which describes how we came about to that. But before we get to that part of the story, I just want to give an overview of this session. And the very first thing I want to say is I am very grateful to people over my career who've taken the time to explain stuff to me. I really appreciate it, and I'll kind of give some examples as we go through the different stories. The other thing, the reason I'm keen to present it, is I've taken a while to learn that we need to use very plain language when we're speaking to stakeholders. If we want to get something done, if we want to make change in an environment and we need our stakeholder buy-in, we've got to use plain language. And I also hope that I can help you avoid some of the mistakes that I made, because that would be a good thing. I did put my foot in it a few times. So minimal operational intervention. The reason this came about is I was looking after a system that supported a couple of different parts of the business, and it turned into spaghetti code after a while, which is the business wanted changes and it was getting more and more difficult to make it. So we ended up with more and more manual practices. And the system was actually a mission critical system. So it was available 24 hours a day, 7 days a week. We had people sitting in the operations area overnight. So we got to the point where our development team were perfectly happy to say, all right, we don't have time to get this done, but it's needed in production right now, so we're going to make it a manual start. And if it fails at any point, then the operations people can fix it and restart it, which was okay for one or two, but of course, there's nothing more permanent than a temporary workaround. So we ended up with lots of these things happening. And if you end up with stuff failing all at once, suddenly you don't have enough people in the operations centre to manage it. So that's when I said, okay, we're going to change the way that we design stuff from now on. We are going to implement this principle of minimal operational intervention. You have to design it so that operations don't have to touch it unless it's a really extraordinary situation. So they shouldn't need to intervene. And I even went as far to say, I don't care if the overnight operations team are sitting there all night doing nothing except perhaps filing their nails. All right. So that's how we got to minimal operational intervention. Now we're talking about the early 2000s. I had no idea about Agile. I had no idea about DevOps. All I knew is I had a VAX VMS cluster. I had tin on premises, and it was pretty hard to manage and pretty clunky. And what we've got now is a lot easier to manage, although there is still a lot of complexity in it. So then the next story is where I started to learn about this thing called code merging. So I sat in an area where I was right next to a bunch of very smart DBAs, and often I'd ponder things aloud and they'd answer my rather naive questions. And this is where some of the stakeholder engagement comes in. I was smart enough to know some stuff, but that made me dangerous. So, of course, I'd have my business people coming in and saying things like, oh, Kim, I know the next release is in a month and the one after that is in 3 months. We are talking about a long time ago. And I really, really need my thing in the middle of that. Can you just kind of slip it in somehow? And so, of course, I go, well, surely we can create more development environments. So the DBA sat me down and they go, Kim, here's what happens when you create a whole bunch of dev environments on this type of on-premises stuff. For every one that you create and every change you make in it, it then needs to be spawned in all of those other environments. And I'm going, why? I truly did not understand it. And they took the time to say, okay, Kim, there's this production version that's out in the real world and people are using it. There's a copy of production, which is what we use to slip in those quick bug fixes when we need to. Then there's P+1, P+2, and if we need any more, we'll make more, but we don't want to because when we even put a bug fix into the production version, we then have to go and put it in and integrate it with any changes into the P+1 and the P+2. So that's when I finally started to understand, and that's made it a lot easier for me to understand this, branch and trunk and code merging things when we talk about continuous delivery. So I'm very grateful for that, because now I can explain why these days, when we do it right, it's a lot simpler. We just have a production configuration. We can take that down onto our own little laptops. We can make changes in there. And because we've got all of the automated release management, testing, everything, I'm being ideal here and idealistic. If I break it, it'll show me I've broken it and I can go and fix it. And then, production is golden and it's all working and it's more resilient. So that's what I learned from asking the silly question of why can't we just have a whole bunch more development environments? Then another thing that I started to do, I got super excited about DevOps. And I also got really interested in line of sight to the end user, the end customer of the system. And one day I stood at a whiteboard and I drew this picture, because this is how I used to see it. Here's the customer. Now the customer has a need and the business person identifies that need. Then the business person goes to the developers and says, build me this thing because customers need it. And then developers chuck it over the fence to operations to operate. And then that somehow gets back to the customer. So as you can see, it's going kind of around and back in that picture. Then I realized that was completely wrong, because operations is actually closer to the customer than anyone else. I always thought the business was closest in that picture. So now the way I see it is you've got the customer, you've got the customer service person or the online if you need it. And then as a grouping, this is not a cloud as in cloud, it's just a grouping of business people, developers and operations people, hopefully all working together to provide the thing that the customer needs. So that means the operations people are closer to the customer in this picture than the original one. And that's when I realized, because my brother also worked at the same organization and his job was QA of packages that were released into the desktop environments. So he was the last person to check before we install a new package and update into that environment, is it going to break anything? And up until I drew this picture, I always thought my brother was furthest away from the customer and further away than I was. As soon as I drew this picture, I realized he was a lot closer than I was, because if he did his job incorrectly, he'd be releasing stuff into production that really stuffs us up. That's a technical term, stuffing us up. So drawing it that way completely changed my view. And in fact, to make a point, sometimes I won't refer to DevOps and continuous delivery as DevOps. I'll call it Ops only, because the way I describe this is the needs of the customer pull the delivery of value into the operational environment. So that's the main thing. Whenever we're wanting to put something new in, we have to ask the question first, how is this going to change and improve, hopefully, how we operate it? And here's where I put my foot in my mouth. One day, I scared an operations manager. I was really excited. I'd been to a conference and I'd learned this wonderful stat, which, I'm jumping to the end outcome. Oh, there's companies out there that can release up to 70 times per day into the production environment. And I said this to a senior operations manager, and the reaction I got was something like that. He nearly had a heart attack. And so I didn't get buy-in. What he told me is only about a month prior, we'd done a major release or tried to do a major release. And 2 weeks prior to that, there'd been a tiny network configuration change that meant that that release couldn't proceed, and we didn't know until we tried to do the release. Me being a smartass, of course, said, well, had we been releasing 70 times a day into production, we would have discovered that 2 weeks earlier. So that's just me being a bit of a smartass. I don't recommend that you use that approach. So what happened in my brain there is I said, wow, if they can release that many times and it's not breaking how they do things, then they must have all of the automation in place. They've got continuous delivery working well. They've got test-driven development. They can roll things back when it's a problem, all that kind of stuff. But it came out of my mouth as they can release 70 times per day into production. So now what I do when I'm trying to get buy-in from a traditional operations person is I'll start with questions like, how long does it take you to detect that something's going wrong, especially after a release? And if there is a problem, can you roll it back quickly? And if you do have a defect in the production environment, how long does it take to build the fix and get it released so that everything's better again? And then I sort of described, well, wouldn't it be great if we did a release and something went a bit weird and we could just kind of snap our fingers, push a button, and it rolls back? And wouldn't it be great if we could detect an issue before it becomes an issue? That would be awesome. But make the fix and roll it in before it has an impact to anybody. I find that way of approaching, which is right at the start of the logic, which is why would we want to change things, is much better than saying, hey, wouldn't it be good if it could release 70 times a day into production? Still remember that conversation. Yeah, so don't do that. The other thing I wanted to talk about is the analogy of building software as a factory. And I think there is a factory in software, but I think we talk about it in the wrong spot. So most of us, when we talk about the software delivery factory, we're thinking, well, there's a design, there's a build, there's a, get it ready, there's a release. And it's like the release is the car coming out of the door at the end of the production line. I don't see the factory analogy as in that part of software. Where I see it is in the production version. The production version of our software is the thing that's delivering the cars out the door, because that's the thing that's doing the highly repeatable transactions millisecond after millisecond. And that's the thing that we want to measure like a factory would. We want to use tools like Six Sigma there, but we don't want to use it in the novel design elements. So the novel design elements are like looking at the factory and saying, we need to change how we're delivering the cars out the door. We need a different type of panel on it. We need a different type of wheel on it. Well, we don't have the machine to do that. How do we redesign the machine? And then how do we integrate that machine into the factory process? So we're still getting cars out the door, but we're getting the new feature on the cars as quickly as possible. So that's how I see the factory analogy being useful in software. It isn't in how we design and deliver. It's how the production version of the code is delivering transactions. So this is the last slide in it, and this is my summary of what I think DevOps and continuous delivery are. So in the old-fashioned world, what we wanted to do was create systems that were what I call robust. And by robust, I mean we make sure nothing bad gets into the system, and we make sure it's right before we put it in, and there we go. When we put it in, everything will be fine. Cross fingers, no one's ever done that. And of course, when it breaks, it can break catastrophically. What the promise of DevOps is for me, and these resilience principles, is the word resilient. So what I want is a system and a set of systems and a set of processes that have all of these concepts built into them. How can I build it in a way that it can automatically detect in production when things are going wrong? How can I build it in a way that it will automatically recover? How can I build the elements of the process as we go along the flow to get something into the production environment so that that is also a resilient process? And I was really happy. I went to a talk by Jez Humble at Lean Agile Scotland a few years ago, and it was called Continuous Delivery Sounds Great, but it won't work here. Now, I had looked at Jez Humble's book at one stage. I'd cracked it open. I'm not a software developer, right? As I say, I'm a helpful business person, knows enough to be dangerous. And that book looked quite technical, so I quickly shut it again. So I wasn't sure if I should go to Jez's talk, but it was a keynote, so off I went. And I was so glad that I did, because that was the talk that helped me to understand all of the things I've talked to you about were actually the principles that are behind continuous delivery. And one of the key stories he told was the one about the weaving looms that Toyota used to produce. So they used to have weaving looms for cloth. That was Toyota. And at one stage, if they had 40 looms in a room, they had 40 people, one standing at each loom, looking at the cloth as it was coming out and checking for defects. And if something started to become defective, they'd stop the machine, fix it, and start it again. And what they did is they built in the ability in those machines to detect common faults. And whenever the machine self-detected the common fault, it would stop and it would raise a little flag. So instead of a room with 40 people around supervising machines, you could have a room with one person watching for a flag going up, where they'd go to that machine, make the fix, and restart it. And that goes back to that minimal operational intervention principle. How can we design what we're doing in any way that means that it can be self-healing, self-recovering, self-detecting, and then the human brain, which is always needed because there'll always be unexpected things, is reserved for the stuff that it's really good at, which is finding novel things when things go wrong and finding good ways to fix it. So in a little summary, what I like about the concept of DevOps and continuous delivery is it takes us towards resilience, and it helps us get away from that mindset and the processes that we have, which are called robust, stopping things from happening that are bad. And when it does happen that it's bad, it's catastrophic. So that's my session, and I can do Q&A now. So I'll stop sharing and go back to video. If I can get back here. There. Good. All right, so do we have time for any questions if people have got some questions or comments?
We do indeed, Kim, and thank you. Not seeing any questions as yet, so I'd encourage people to please post some questions in the chat room or the Q&A. That would be awesome. And whilst we're waiting for that, I just wanted to thank you, Kim. That was really interesting. Always a great topic on self-healing and self-detecting. So,
yeah, it wasn't until I saw that Jez Humble talk that I suddenly realised all these things I've been doing over my career and all these little things I'd learnt suddenly came together. It's like, oh, I do think in a way that's consistent with continuous delivery, and it's not as hard as I thought. It is hard, but it's not as hard as I thought.
Yeah, great. Okay.
We have a question from John. How do you recommend we go about identifying the most critical points of failure in our systems and improving them to be more resilient?
Ooh, I love that one. So I'm a big fan of metrics. Now, I'm not a fan of what I would call target metrics. You know, we need to get this many things by this amount of time. I'm a big fan of monitoring metrics. So that's where I would, in a production system, what I would be looking at is what is the mean time to recover? Of course, that is a state of DevOps thing, isn't it? The mean time to recover is one of the key metrics. So when there is a fault, how long does it take to detect? And how long does it take to get us to restore? That would help me prioritize, because if I had 100 things happening of the same type and I could do one thing to fix those 100 compared to one thing that only ever happened once in a while and didn't have a big impact, that's how I'd prioritize it. So I'd be using metrics like mean time to recover, and I'd also be looking at what is the manual effort we're currently spending on things. Does that help answer the question? I just want to check that I've answered the right question.
I think it has. We'll wait to see what John comes back with. But we have another question from NM. How do you see this evolving post-COVID?
Ooh. Oh, well, what my hope is, it's always easier to get the attention of stakeholders when you've got a real example of an issue that's occurred. Because, and if anyone's ever done any risk analysis, when you rate a risk on impact and likelihood, so when you look at likelihood, if the risk has never happened before, you can imagine that it's got a certain rating. But if you can say this risk has actually happened in the past, you automatically bump it up in criticality. So it's got a higher likelihood of occurring. So I know we're all super busy, especially if we're in operational and delivery roles right now. But if we've got an opportunity to take note of some of the things that we wish we could have fixed before we reached this situation, and we've got good examples of the actual impact, then it's going to be a lot easier to get our stakeholders on board and say, yep, we've always said that we should do this, and guess what? It happened, and this was the impact. So if we go and fix it, it's likely that we won't have this kind of impact again. So I think there's an opportunity there for post-COVID based on what we're seeing happening during the situation. Yeah. I'm super happy if anyone ever wants to reach out to me either on Twitter or on LinkedIn. I am doing posts every Sunday on LinkedIn now, which are proving quite popular. People keep asking me questions about them. So I'm very happy to take questions about any of these topics or any of those topics.
Thank you. That's awesome.
We have another question, a latecomer.
Cool.
From Mujo. What approach do you recommend for optimization? Small changes with small benefit or large with large?
Ooh. There was a really good talk by Martin Fowler at Agile Australia. I think, was it last year or the year before? And he talked about code refactoring. And he said a lot of people have misinterpreted what he meant by code refactoring, because what he meant is making changes that are so tiny no one notices them, so that incrementally over time you improve the health of the code base, right? And the reason he knows people are misinterpreting it is because he'll say, why aren't you refactoring? And they go, well, I can't afford to take my systems offline for 2 weeks. So he pointed out that's a misinterpretation of code refactoring. But when it comes to in general, should we make small changes or should we make big changes? It's very easy to say, let's just do the big change. I've done it myself. I've run programs of work where we have replaced that entire system. That entire system where I had the DBA sitting next to me, we ended up replacing that completely. That's a 3-year project, many millions of dollars it cost. And, people using it now are very happy because we did have spaghetti code. So there was no way we could do the small incremental changes. There are good reasons to do both, and I wouldn't do one over the other. I would look at the situation and say, does it make sense to stop, throwing good money after bad on this spaghetti thing, or do we just keep making the small incremental changes? I think, does that answer what you're asking? That's the question. I am actually a big fan of taking small steps towards things. I get a bit scared when I go, oh, there's this big thing, let's just do this big thing. I'd rather take the small steps toward it if I can.
Well, we have another question from Mujo. How about systems performance instead of code?
So has something systems performance?
How about systems performance instead of code?
Not quite sure I understand the sense of that, but I've had years ago, IT architects tell me that when a user, so this is for a front of house system, when a user presses a button and the screen response time is 7 seconds or less, that's okay. Now that person had never ever worked in a call center. My first job at a big telco was in the call center. And I know as soon as you hit that button and the screen takes, it's still under a second, but close to a second to refresh, what you start doing with the customer on the phone is distracting them, because you don't want to keep saying, sorry, my systems are slow. You end up saying, oh, so what's the weather like in Upper Kambukta West, Mrs. McGillicuddy? You do things like that. So systems performance, to me, how the operational version of the system is working, how it's performing for the end user, for the end customer, is the main focus. If we're writing code for new features and we're not taking that into account, then we're wasting an opportunity and we're putting an already heavier burden onto overloaded people. So both the customers trying to use the system and the front of house users trying to service them. So yeah, systems performance to me has to be the first thing that we worry about, because it's no good having fancy features if it takes 7 seconds to refresh the screen. I think that answers the question. That's the question I thought you asked. Apologies if it's not.